The Strait of Gibraltar has seen a lot of action over the centuries. The Carthaginians crossed it during their wars with Rome. Christians and Muslims fought over it, and during World War II, German U-boats tried to sneak through it to evade Allied warships and enter the Mediterranean. This narrow waterway separates Africa and Europe. It's been a key landmark for humans for thousands of years. People have used it to migrate between North Africa and the Iberian Peninsula, but always by boat. Even today, the only way to cross the strait is by ferry unless you're up for a long swim. Despite the shortest distance being just 9 kilometers, about 14 miles, no one's ever built a bridge or tunnel to let people walk across. But why? The Strait of Gibraltar connects the Atlantic Ocean and the Mediterranean Sea, stretching about 36 miles, that's 57 kilometers long. The narrowest point lies between Point Meraki in Spain and Point Ceres in Morocco, measuring just over 8 miles. Roughly the same distance between San Francisco and Oakland. On a clear day, you can see across to the other side. The average depth of the strait is around 1,200 feet, 365 meters. This waterway is one of the most crucial shipping channels globally because it's the only natural link between the Mediterranean Sea and the ocean. Unlike the man-made Suez Canal, the Strait of Gibraltar is much larger, making it easier for big ships to navigate. Every year, over 100,000 ships pass through the strait. For comparison, the Panama Canal handles about 14,000 transits annually, and the Suez Canal sees around 20,000 ships. Many vessels traveling through the Strait of Gibraltar are heading from the Western Hemisphere to deliver goods to the Middle East, Africa, and Europe. There's also significant traffic going further east to Asia and China. At the same time, ships travel west, bringing goods from the Middle East, Africa, and Eastern Europe to Western Europe and the Americas. The Strait of Gibraltar's proximity to the oil-rich Middle East means massive amounts of oil and natural gas pass through it. Over 300 oil ships navigate the strait daily. To give you an idea of the scale, a smaller tanker can carry between 70,000 and 190,000 barrels of oil, which translates to about 3.2 to 8 million gallons. Larger tankers carry between 190,000 and 345,000 barrels, equating to around 8 to 14.5 million gallons of oil. On a busy day, roughly 2.4 billion gallons of oil flow through the Strait of Gibraltar. In comparison, the United States consumes about 20 million barrels of oil per day, or about 840 million gallons. This means the oil passing through the strait on a busy day is nearly 3 times the daily oil consumption of the United States. The strait's a critical route for global shipping, bringing significant revenue to the countries bordering it. This has led to the development of major ports and shipping facilities, like the Port of Algeciras in Spain, one of the largest in Europe and the Mediterranean, and the rapidly expanding port of Tangier Med in Morocco, essential for African trade. Both Spain and Morocco are increasing their port capacities along the coast. Given the economic benefits from trade and tourism, you might wonder why a bridge hasn't been built to connect these two parts of the world. So what's standing in the way? It's no surprise that one of the main things stopping a bridge from being built across the Strait of Gibraltar is the political situation between Spain and Morocco. There's a lot of tension and disagreement between the two countries, and not much consensus. When it comes to building the bridge, there are 2 big concerns about who will fund the project and how it benefits each nation. Disputes over territories like Ceuta and Melilla complicate cooperation. Both nations would need to agree on numerous issues, from construction oversight to revenue sharing, which is no small task given their rocky history. Gibraltar adds another layer of complexity. The UK's control of this strategic point is a contentious issue for Spain. Any project would need to navigate these political waters carefully to ensure all parties are satisfied. The concept of a link between Spain and Morocco dates back to ancient times. The Greeks and Romans called the strait the Pillars of Hercules, marking the edge of the known world. Fast forward to the 20th century, and the first serious plans emerged in the 1930s, with proposals ranging from bridges to underwater tunnels. Each time, the plans were shelved due to technological limitations, political discord, or financial constraints. In the 1970s, the Euromed transport project rekindled hopes of building a link, but once again it fell through. Each subsequent decade saw new proposals, from floating bridges to underwater tunnels. Some were visionary, like the idea of a bridge supported by giant pylons or a tunnel resting on the seabed, but all faced insurmountable obstacles. One of the biggest challenges is the depth of the Strait of Gibraltar. As we said earlier, at its narrowest point, the water is around 365 meters deep. Building a bridge over such a deep chasm would require massive foundations. Engineers would have to sink pylons deep into the seabed, which isn't simple. The seabed is composed of unstable sediments, making it extremely difficult to secure anything solid. Pylons would have to penetrate deep into the seabed, potentially hundreds of meters to find stable ground. This process is technically challenging, time-consuming, and expensive. Then there are the powerful currents. The strait acts as a natural funnel between the Atlantic Ocean and the Mediterranean Sea. Water flows in from the Atlantic at a tremendous rate, replenishing the Mediterranean, which loses water to evaporation. These currents, along with tides, make any underwater construction incredibly challenging. Workers would face constant movement, making precise work nearly impossible. This would further require highly specialized equipment and techniques to stabilize the work environment, adding further complexity to the project. Even if we could stabilize the seabed and manage the currents, the next issue is the shipping lanes. Over 100,000 ships pass through the strait each year, including massive cargo ships and oil tankers. A bridge would need to be high enough to allow these giants to pass underneath, meaning a height of at least 100 meters above the water. This would make the bridge one of the tallest ever constructed, presenting its own set of engineering challenges. Another major concern is that the bridge design would need to ensure it doesn't interfere with the complex navigation of ships through the narrow strait. The structure must be resilient enough to withstand potential collisions and constant vibrations from passing ships. Additionally, the Strait of Gibraltar lies on a tectonic plate boundary where the Eurasian and African plates meet. This area is prone to earthquakes, posing a significant risk to any large-scale construction. The 1755 Lisbon earthquake, with an estimated magnitude of 8.5 to 9.0, caused widespread destruction across the region. Any bridge or tunnel would need to be designed to withstand such seismic activity, which adds to the engineering challenges and costs. Earthquake-proof structures require advanced materials and design techniques that are not only expensive but also still developing. An alternative to a bridge is a tunnel, an idea revisited multiple times over the decades. A tunnel could bypass some issues associated with a bridge, such as the need to accommodate ship traffic. However, tunneling under the Strait of Gibraltar is no simple feat either. The Channel Tunnel, which connects the UK and France, spans about 50 kilometers, and that took 6 years to build. It faced numerous challenges, but the geology of the seabed was relatively stable compared to the Strait of Gibraltar. In contrast, the strait's seabed is highly unstable, composed of those tricky clay channels. These can shift and buckle under pressure, making traditional tunneling methods problematic. Engineers have considered different tunneling techniques, such as using a submerged floating tunnel. This would involve creating a tube that sits about 100 meters below the water surface, anchored by cables to the seabed. It would avoid some of the seabed instability issues, but would still need to withstand the powerful currents and the risk of collisions with passing ships. Then there's the financial aspect. Building a bridge or tunnel across the Strait of Gibraltar is an incredibly expensive endeavor. Estimates for such a project range from $5 billion to $20 billion, depending on the type and scale of the construction. Funding such a massive project requires significant investment from both governments and possibly international investors. The economic benefits, while potentially substantial, are not guaranteed. Governments would need to see a clear return on investment to commit such large sums of money. If it brought in massive amounts of revenue through tourism or the movement of goods, that'd be different, but it's not the case. Numerous committees and businesses have assessed the feasibility of this project. Many have concluded that building a bridge could be possible, but there are significant obstacles to overcome. Despite these challenges, there are glimmers of hope. Advances in engineering and technology may one day make this project feasible. Political landscapes can change, paving the way for better cooperation. There's even a potential $25 billion plan in place aiming to bridge the gap. This ambitious project, still in its planning stages, promises to revolutionize travel between Europe and Africa. But as with all grand endeavors, it faces a mountain of challenges before becoming a reality. The dream of connecting Europe and Africa with a bridge or tunnel is an epic tale of ambition, challenges, and potential. Whether or not it becomes a reality remains to be seen. We are committed to releasing 2 videos a week. Like, share, subscribe, and hit the bell icon for more visionary builds.